Okay, so I've had some questions about big O of functions. So remember, the only cop you're going to have to do will be, for the test, are going to be polynomials. So let me just remind you of the key important, the important key fact we use whenever we do polynomial functions. So here we have graphs of 4 different functions. Here is the graph of y equals 1. Here's the graph of y equals x, the blue one. Here is the graph of y equals x squared, the red one. Here's the graph of y equals x cubed, the, I guess that's orange. So this is what we have to notice, okay? Whenever we're less than 1, that is for x values smaller than 1, then y equals 1 is the largest function, x is next, x squared, and then x cubed. But here at 1, when x is equal to 1 on the x-axis, here everything turns around. And from this point onward, 1 is the smaller function. It's below the other ones. X is the next largest, x squared is the next largest, and then x cubed. Okay? So this is the key fact we use to do all of these problems, is that as long as we're taking x values that are larger than 1, okay, then all of these properties hold. So here's an example that is very similar to anything that you're going to see on the test. All right, we want to show that this function f of x, which is 4x to the fourth plus x squared plus 2x plus 1, we're going to show that this thing is x to the fourth. Okay, so this function is a polynomial, which is the kind that you're going to see on the test. I'm only going to have you do polynomials with positive coefficients. So keeping in mind all that stuff we said on the previous slide about where things change at 1, we're going to use that, and we're going to say, well, for x greater than 1, then a lot of really nice things happen. Okay? Remember from all the examples we've done in class that we're trying to show that this function is less than or equal to a constant times this function. And the way we do that is we want to replace each and every term by something that is larger in terms of x to the fourth. So what we note is, as long as we have x greater than 1, we have that, well, first of all, we have that 1 is less than x to the fourth. We have that 2x is less than 2x to the fourth. We have that x squared is less than x to the fourth. Okay. Why does this work? Well, as long as x is bigger than 1, we're past that point on the graph. So these higher degree polynomials are bigger than the graph of 1. Also, x to the fourth is a bigger function than x, so 2 times x is smaller than 2 times x to the fourth. And x squared is smaller than x to the fourth. And I just realized that kind of looks like I wrote x4, so let me fix that. That should be x squared is less than x to the fourth there. I think that looks a little bit better. All right, so what do we do with this information? Well, 4x to the fourth plus x squared plus 2x plus 1. This is going to be less than or equal to 4x to the fourth. So all I'm doing there is I'm just rewriting this term plus 4x, excuse me, that's a mistake, plus x to the fourth. So what did I do here? I replaced x squared with x to the fourth. And I can do that because of this inequality. Plus 2x to the fourth plus x to the fourth. And so for those last two, all I did was use the fact that 2x is smaller than 2x to the fourth to make this replacement, and 1 is smaller than x to the fourth to make this replacement. And so when we add everything up, this is going to turn out to be equal to, let's see, 4x to the fourth plus 1x to the fourth is 5, 6, 7, 8. So this is 8x to the fourth. And, you know, now we're done, because we just take k to be 1 and c to be 8. And that does it. That shows that this original function right here is big O of x to the fourth, because I found a number k that if my x's are bigger than this number, then my function is smaller than a constant times x to the fourth. And this is exactly how you will do the problem or potential problems on the test. You'll take x bigger than 1, you'll make all these replacements like this to find this number, and then note down what they are, and that's all you'll have to do. So I hope you find that helpful. Let me know if you have any questions.